Good morning, day, afternoon, or evening or night, whenever you're watching this video. This video is geared towards talking about relearning target 6A from Algebra 2, semester 2. So let's go ahead and get started and begin to talk about this particular target. So the first problem that we have has a couple of steps to it. And if you recall for 6A, our focus is really about being able to describe the effect of a transformation. So being able to describe it in words, being able to describe it when we see it from a graph, from a table, what have you. So this first problem you see here, it gives us a graph of f, and we're asked two different things to do. The first thing we're asked to do is to sketch a graph of that function and make sure we reflect it over the y-axis and then translate that same image 3 units up. So if we go ahead and work this out, I'm going to go ahead and start by doing the reflection. Now, to help us with reflection, or really in the transformations we want to do, it really does help if we're looking at a graph that we try to find some points that we're able to pinpoint. So for example, I see this point here that's on the x-axis. It's a little after the 2, and so I'm going to use it as kind of a focal point to translate this or to reflect it over the y-axis, which is right here. So that means if I'm a little after 2 on the right-hand side, when I reflect it or flip it over, I'm going to be a little bit past -2 on the left-hand side. Now, can't really use this point here, but that's going to be a point that the two are going to share. So I can use that to mark my graph, if I will. So another good point I'd probably use would be like this -4 looks like about right here. So a little above that -10. So when I reflect this point the other way, because we got to reflect it as well, it's going to be in that same line that you see me draw, but it's going to be at the 4. So just kind of do my best to set the graph there. Okay. So from there we have it, and that's what would happen if we just did the reflection. But that's not the only transformation we need to do. We need to also move all of those points up 3 units. So where this is on 0, I need to move this up closer to the 5. So I'm moving it up 3. I'm going to change my color. I thought I changed my color. I did not. There we go. All right, let's see if this changes. Yep, there we go. This point here, which seems about halfway, I need to move it up 3 units. So let's say we call this 3. We're going to move it up to here. This point here, we'll call it maybe -8. I'm going to move it up to -5. Now we're making a sketch, so you want to try to get as accurate as you can, but if you're off just a little bit, it's going to be perfectly fine. And so since those are the transformations we have listed, this yellow graph is the one we want at the end for question A. Once again, the red dots you see, we're just talking about the reflection. So that was me reflecting over the y-axis. But when I ended up doing the yellow, that combined the reflection and to translate this graph up 3. So that takes us to B, which says to write an equation in terms of f for a function g that the graph that has the graph that you drew. In other words, what this is saying is that new equation, the one that's in yellow, is going to be called g of x. But when I write it, I'm going to use f of x as like the input or the item that I had at the beginning. So the best way I can describe it, if you think about if you have a t-shirt and you were to tie-dye it, the t-shirt's still there and everything you describe about it is based on what you did to the t-shirt. So I'm going to have f of x as the thing I'm going to use. So now, first we reflected this over the y-axis. When that happens, that means a negative is in front of the function that we're changing. So I'm going to use the red to show you that part, and that does align to our graph. Then from there, we also move the graph up 3 units. So to move the entire function up, we put +3 at the very end. And so what you see here now written as g of x is equal to -f of x plus 3 is the function notation representing this yellow graph. So hopefully with it being color coded, it's a little bit easier to see the connections there that we use the description to make a sketch, and we showed those transformations graphically. And then we also showed it using the equation. Let's go ahead and move to problem number 2. Problem number 2 asks which of these equations could be true for all values of x. So once again, this is still in this family because we are still focusing on using the function notation to be able to demonstrate what's going on. So when we look at this, we look at our table, we have f of x, but all of these f of x are written in terms of how did you change g of x to match it. So when we look at these values, what we notice first of all is that these numbers are flipping. So from the x to the y, we'll notice that instead of going from the top to the bottom, g of x is going from the bottom to the top if we look at the values. Meaning where f of x has has 4, 2, 1, 1/2, and 1/4, g of x starts at 1/4, 1/2, they meet at 1, so at 0 they're both at 1, then we have 2 and 4. Because that happened and they meet at a certain point, that does illuminate that there's a reflection that has transpired. So that's the reason why we're not going to choose D, because D is saying that they're both the same, and that's not true. So now we need to figure out how did these things flip around. And what we notice is if we think about it, if a graph were to reflect over the y-axis, then that means the x values are changing numbers. So you kind of keep the same y, but you're just changing the x values. But what's happening here is that we see, so if we were to, what we see here, so okay, let's actually just sketch this. Maybe that'd be an easier way to describe it here. So for f of x, now use purple, at -2, we're at 4. At -1, we're at 2. 0, we're at 1. 1, we're at 1/2. And 2, we're at 1/4. So then let's go ahead and do g of x, which I'll use the pink color for. So at 4, this one's at 1/4. At -1, we're at 1/2. They both are at 1 when we get to 0. At 1, the g of x is at 2, and when we get to 2, the g of x is at 4. So what we notice is there's a slight mirroring that's starting to happen over the y-axis. So when that happens, that means there's a negative applied to the entire function. That only happens when we look at this, that would only happen if there's a negative in the very front. Now, the B option, which we're not choosing, this is if you reflected, let me make sure I say this correctly. Nope, I'm wrong. Nope, I'm wrong. Let me fix my error. I made a mistake. It is all good. I'm writing what I'm saying, but I chose the wrong graph. So this is reflecting over the y-axis, okay? Which means the y values are staying the same. It's just the x part is changing. So when it reflects over the y-axis, that actually is the reason why we choose option B. Just like you, I get kind of mixed up from time to time. So B will be the option there because what that's showing is when you drop in your x, it's gonna change it over and it flips around. That's what is occurring here when we look at that reflection over the y-axis. It wouldn't be A because a negative in front reflects it over the x-axis is what ends up happening. So this is saying you do whatever the function tells you to do, and then you put a negative at your answer. And then C is just a combination of both. So let's take a step back. Let me fix problem number 1 here. Because graph number 1, because as you're thinking, hey, we reflected over the y-axis and you put a negative in front. But you're now saying in problem 2, when you put a negative in front, it's going the other way. So let me fix this. This is how I know I made a mistake in problem number 1. This negative should not have been there. That's on me. The negative is actually going to be inside with the x, so we keep it consistent. See, I told you, sometimes I make mistakes trying to remember things and all the rules just like you are. So what you see now on the screen is the correct answer that we have. Okay. All right. So problem number 3. It says a pumpkin pie recipe says to bake the pie at 425 degrees Fahrenheit, 15 minutes, and then try to adjust the temperature down to 350 degrees Fahrenheit for 45 additional minutes. The function P gives the oven temperature setting P of T. Go ahead, you're fine. In degrees Fahrenheit, T minutes after the pie is placed in the oven. So we're asked to kind of talk about the situation, and we should be able to do it with or without a graph. So we're going to do this one without a graph before us. So A asks us to explain what P of 30 equals 350 means. What that means is the following. It means that when you're cooking, it means at the 30-minute mark, the oven is at 350 degrees Fahrenheit. That's what that means. So when we look at our marks, first 45, 425, the last 45, so 30 minutes in would be getting to that point. We're at 350 degrees. B says Diego discovers that the temperature inside the oven is always 25 degrees warmer than the oven temperature setting, which is not abnormal, especially when we think about different cities. The function B gives the additional temperature of Diego's oven. If P of 30 equals 350, then what is the corresponding point in function B? So this is saying that they are saying that it should be 350 at that point, but Diego's saying that the oven is earlier. So it would be for the B function, so we said B of 30, the temperature is actually going to be 375. So C asks us to write the B function in terms of P as far as what's happening. So we have B of, and we'll just call it T because that's the temperature. And that is equal to, now we have this P of T again. But what's happening is whatever temperature you get from what this says should happen, we add another 25 degrees just like you saw me do in B. So this would be the function that goes with it. Now, I know one of the things that you may have been wrestling with is trying to show the transformation and tie it in the parent function. The point of this unit or this target is not so much you to memorize the parent function and the shapes. The point of it is to say, regardless of what the function is, regardless of how it initially acts, these transformations that we talk about, going up, down, left, right, reflecting both ways, and even when we talk about the stretches and shrinking vertically and horizontally, it can apply to any function that we have. Some functions you'll be able to see it, other functions you will not, but it is still having the effect that we're looking for. So that is the end of 6A. At this time, you should be able to transition, go ahead and do the practice. And until next time.